with Vollprecht. I'll try to get that right at some point. G'day, Wolf, as we say here.
Hello.
How are you?
I'm very good. How are you?
I'm well, thank you. So you're in Berlin currently?
Yeah, I'm just getting my morning coffee.
And I'm in Australia. So it's definitely far later in the day for me. It's the end of the day. Just give me 1 second. I'm gonna make sure this stream is going to is working. It is. Sorry about that, everyone. There was a slight glitch on my end. So we are starting. If you wouldn't mind introducing yourself in the chat, as we just discussed, I am in Sydney and Wolf is in Berlin. If you could let us know where you're calling from or where you're watching from, and what your interest in these things are. Do you work in data science or machine learning or AI or these types of things that help us set the stage for the conversation as well? So please say hello in the chat and let us know. While you're doing that, I'll just say a few more words by way of introduction. This is a monthly Fireside chat series we have at Outerbounds, where we work on infrastructure and productivity tools for data scientists, such as Metaflow, an open source framework for the full stack of machine learning and AI infrastructure. We do this a lot through the open source framework, but we're very excited to be working on Outerbounds platform as well. So check out Outerbounds if that sounds of interest. Also, if you are interested in open source frameworks for full stack machine learning, please do check out Metaflow. And I'm going to post the link to our GitHub repository there. And if you like it, please star it and share it with friends. Also, hit subscribe wherever that thing is if you like this, and share this with friends as well. This is cool. We've got people so far tuning in from Paris and Singapore. So we have Paris, Berlin, Sydney, and Singapore. So both APAC and the continental Europe represented thoroughly. And we have someone from Melbourne, Australia as well. For another person from Berlin. Is Cheyenne your colleague?
No.
We have multiple people from Berlin as well then. So look, and we have Sarah Burnett from Auckland as well. Hey, Sarah. And Sarah joined a workshop I taught last week. So great to see you again, Sarah. So I'll say a few words about you, Wolf, and you can then choose to accept your biography or not, or dare to challenge me. No, I'm kidding. Right. You sent me the biography, but that was for something else. But Wolf has spent the last 5 years trying to make sure that the conda ecosystem can grow unbounded! Wolf worked at Quantstack, and did C++, numerical computing with xtensor, Jupyter, and Mamba before starting his own venture, Prefix, where they're trying to take package management to the next level. And so let's jump in Wolf. I do want to say, people, if you've got any questions throughout, please ask them in the chat on YouTube. We'll do our best to get to them. So without further ado, Wolf, maybe I'd love to know just a bit about your history and how you got into this space of data, ML, AI, and package management more generally.
For sure. I didn't actually start out as a data scientist or even computer scientist, I would say. I did some programming on the side during high school, but then I went on to study mechanical engineering and robotics in my master's degree. And that was obviously already going pretty far into the computer science domains. And I got really interested in making numerical computations faster and implementing NumPy in C++. And I found this project xtensor. And through that, I basically started at Quantstack as more or less the first employee. And then at Quantstack, we were already using conda Forge a lot, and conda as a package manager for all of our C++ projects, actually, which is something you might not expect from conda. But basically, through that, I kind of got into the whole package management space. And robotics is also playing a part in that, actually. So.
Yeah, and so you got started as a hobbyist, is what I'm hearing, and then made a career out of it. Is that?
Yeah, I think that's basically it. I mean, there was a lot of sort of interest, like intellectually and in what I was doing, and that kind of started that career.
So I really do want to get into the weeds, both for data scientists, machine learning engineers, analysts, people who on the user facing side have package management challenges that they don't want to have and that you want to make easy. I want to get into the nitty gritty of that. But first, I just want to ask a really high level question that I still don't have a good answer to. Why is package management hard?
Well, I mean, there's a lot of different hardware out there in the first place, and also a lot of different software. And software evolves, hardware evolves, and the software also comes with dependencies. And so you're basically sitting on a train that's always moving, and you need to figure out what works with what, and how do I combine these things to end up with a working environment. And I think that's what makes package management hard in that sense. Everything is evolving at the same time and not in a coordinated fashion. And so you have distributions that are trying to kind of coordinate these things, and conda is one of these distributions that is trying to coordinate these things. And then you also have another solution, which is basically taking snapshots, which is what Docker does, or Nix packages, which are kind of like having one state that is like set in stone.
That makes sense, and I like the analogy of being on a train that's moving very quickly. I think, and also perhaps different parts are moving in different directions, perhaps
Exactly
as well. And from my perspective, just to set the stage for people here, and I assume a lot of viewers and listeners have similar challenges. From my perspective, part of the challenge is that I just want to like have an environment locally where I have like PyTorch and Pandas and scikit-learn and whatever, like data shader, whatever it is, right? And that's hard enough on my system. Then I want like some, transformers or whatever it is. But then I want to be able to leverage cloud compute, some clusters my, infrastructure engineers provision for me or whatever, and make sure that the package management story stays the same between those. And I would have used, when I first started working in data science, I was using Conda. Then I've used Mamba and Poetry, and of course used Pip among other things. Conda didn't always exist, right? In the data space, it evolved itself. So I'm wondering if you can give us kind of a brief history of package management in Python for the data ML and AI space from kind of the genesis of Conda.
Yeah, like I'm not a historian, but I have some idea of the history of that. So I think Pip
I don't think any
existed.
historians could answer this question as well, by the way. I think you're probably one of the only people around who could.
I think Pip existed before Conda, but Pip was very much geared towards like what's called SDIS. So that's just like source code. And source code is not super easy if you have to build it yourself, especially if there are like C extensions involved, which is something that a lot of the data science world needs. And Conda was kind of the first, or maybe one of the first attempts at solving that. I think there was something from Nthought before, which was called EDM or something like this. I haven't used it. And there's also Active State Python, which is also doing something like this, I believe. But Conda has basically tackled this problem before the emergence of wheels, which came later. And the idea was that instead of downloading a source distribution where you have to run the C compiler to compile the code yourself, which is very brittle and very difficult, you would ship a whole distribution that contains everything, including like the binary compiled things for like Linux, for Mac, for Windows. So NumPy, for example, is a library that has a lot of C code in there and maybe even Fortran. And that needs to be compiled into shared libraries that Python can load and interface with. And Conda made that really, really easy. And then later on, the PyPA also followed up with wheels. And before that, there was something else that I just forgot, but it's deprecated now.
Okay.
Anyways, yeah, and wheels are basically kind of similar ideas to conda packages in some ways, where you have the compiled artifact inside of the package that you download, and makes it much easier to install than a source distribution.
Great. Cool. So we have the emergence of conda and wheels, and then what happened between that and the emergence of Mamba, and why? Maybe you can tell people what
Yeah,
Mamba is and what motivated you
for
to
sure.
add to the story.
Yeah. So Conda and Conda Forge especially experienced a lot of growth in like 4 years ago, and still experiences a lot of growth actually. In terms of like how many packages are there, and then also how many package versions are there, because package versions are purely additive in a way. Like our repository and the way it works is just like continuously growing and growing and growing, right? Because people are publishing new versions. And Conda became extremely slow at some point. Like it also got better afterwards, but it was at some point really unbearable. And I also had this crazy idea of putting a lot of the robotics packages that I used in my studies and also later in my job on Conda Forge. And I thought this isn't possible with the current state of like the Conda world. And that's basically what led to the creation of Mamba. Was this like I saw that there's something kind of interesting and good, which is like Conda packages. They work really well on different platforms and everything, but it was unusable for what I was trying to do. And so over one weekend, I was playing around with a library called libsolve. And that's a library that's used in Linux distributions like Fedora for their package manager called DNF. And it's basically a SAT solver. And that was actually the slow step. So the SAT solver is the program that's responsible for figuring out what versions are compatible with what versions. Like if I pick the latest NumPy, what version of Python do I need to pick, and what version of, I don't know, bzip2 do I need to pick, and to like make everything match. Because each package defines these little constraints. Like for example, Python might say I work with bzip 1.5 up to 1.10. And then the SAT solver needs to make sure that everything else also confirms these same constraints. And yeah, I looked at Conda, and I don't know if you were born in these times, there was like this spinner that was spinning and spinning and spinning, and it was kind of driving me nuts. And that was actually the SAT solving that took so long. So I tried to use libsolve. I hacked something together, and then it sort of worked. Like at least it was maybe, well, it was kind of a proof of concept that there could be something that works. And I went back actually to the original author of libsolve, and I told him, hey, I tried this and that, and like kind of works, and didn't really hear from this guy. And then like a week later or something like this, he had written this entire file that was called conda.c and conda.h. And yeah, he just like implemented the whole version spec matching algorithms that you need to deal with conda packages.
Amazing.
And yeah, and then I tried to integrate with that, and it started to look better and better. And then we built a lot of the scaffolding around how to deal with conda packages in C++ and built that into Mamba and evolved it from there. But yeah, really that libsolve work was what was kicking it off back in the days.
Okay, great. So I want to bring this background to the data science experience soon, but I do want to know what happened next. I mean, because now we have, we don't only have Mamba, we have Poetry, we have UV, we have Rattler. So
Yeah.
And
Pixie.
And Pixie. So take us through all of these with the journey to Pixie.
Sure. So first of all, like there's these two ecosystems, Conda and Pypi, right? And people that use Conda, they also often use Pypi in conjunction with Conda. But Conda is usually used to set up like also the base system. Like you want your Python, you want your Node.js, you want your Lua or whatever, like programming languages, or even more low level, almost system level dependencies up to glibc is what you typically get from your Conda packages. And then for your Python specific stuff, you can always refer back to Pypi. And so there's a sort of evolution of tools in the PyPI space and also an evolution of tools in the conda space. And in the PyPI space, you have what you said, like pip is sort of the default pure Python battle tested tool that has been used for ages and is shipped as the default installer for PyPI packages. And then there's Poetry, which followed a few pretty cool like modern ideas and also has a different sort of resolver algorithm and a few bells and whistles, and a lot of people seem to like it. But it's also written in Python, and UV, which is the new tool that is written in Rust, really fast installer for PyPI packages essentially. And on the conda side, so there was conda, and then there was Mamba. And we are working on something called Pixie now, and Pixie is the user-facing tool. It's also written in Rust, and it's a bit more like Poetry with regards to some ideas. And it actually also integrates with UV to combine it with PyPI packages. And below Pixie, we have a library that's called Rattler. And Rattler is our set of Rust crates that are really easy to use to deal with conda packages. Like you can rewrite conda using Rattler in like 2 lines of code, more or less, like conda create, let's say. So yeah, we're trying to build like a really foundational library there to deal with these packages. And then on top, we're building Pixie. And Pixie, like if you're a user of data science tools and stuff like this, the tool you should try and use is Pixie. You should just go like download it, do Pixie init, Pixie start, blah, 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 and have a very, very nice, extremely fast experience.
And you should stick around until the end of this live stream when Wolf demos some cool stuff on Pixie, maybe even getting into the foundation model space. We'll see, or all the AI stuff people are working on now. I've also just linked to prefix.dev in the chat. Check it out. Also, Wolf, congratulations on starting to build a company and all the great work you're doing there. So I can't wait to see what happens next at Prefix. I am interested in, so I know you can't speak for all data scientists and machine learning engineers, but just generally you work on solving their pain in a lot of ways. So I'm wondering what type of challenges do data scientists, MLEs face in shipping software that keeps you up at night, or that you think about and care about?
I think a lot of like it's always been a bit of a challenge to kind of like take your experiments and then productionize them, right? Like go from your like daily work to like the thing that you want to deploy. And package management is one ingredient that can help to make that easier. And in Pixie, we are actually shipping some ideas that we think are really like sort of taking it to the next level in terms of how you can go from your working daily code development environment to like a production environment. And another pain point that we see is collaboration. Like we really want to make it easy for people to share their code and their development environment with their colleagues. So what we have in Pixie is these development environments that come with a log file. So you have exactly locked down versions of the things that you're using on your machine. And if you send it and check it in your Git repository, your colleagues will get exactly the same version. So it's almost like a Docker container without the hassle of a Docker container.
Yeah, but what if my laptop's like M1 Intel based or some and you, like, are there more challenges introduced by individual hardware that we have?
Yeah, for sure. Like you also want to get the most optimal package for your system without needing to run any emulation and stuff like this. And that's why in Pixie you can always sort of select multiple platforms that you want to have this running on. And we will take care of everything, like solving it under the hood, making sure that it basically selects the best packages for all the different platforms that you want to support with your project. And your coworkers, they just need to run Pixie run start or something like this. You can ship with different tasks, like pixie run start could start up a Jupyter notebook, or it could start training, or like you could have another task that says train, and then you could do pixie run train, and then it starts training your neural network or things like this. So it's a very flexible system.
Very cool. Just quickly, Will has written in the chat, "Hi from the US. Love the late night live streams." So that's awesome. I'm interested in what the key elements are on your side needed to make package management seamless and reliable across different stacks and platforms.
Yeah. So for us, I think like the key elements are that, like, I think the key elements are actually in the conda distribution. Okay. One thing, I don't know if people in the chat are generally familiar with conda, but it's a repository with over 20,000, I think more than 20,000, like way more than 20,000 packages. A lot of them are in the Python and ML space, but also like really sort of fundamental stuff like bzip, Python, I don't know, like libraries like that, or xz even, all this kind of stuff. And conda distribution is kind of maintaining all of these recipes for the different packages and then building them on CI systems. And that's actually a key point, is that for Pypi, you don't really know where the package is built, right? Like it's just like someone does it maybe on their computer, maybe on like a CI pipeline, I don't know where. And then it gets uploaded to Pypi, and the configuration and stuff like this is not really clear. What is different with conda is that there's like a centrally managed configuration file that says, okay, we want to use this compiler on Linux, that compiler on macOS. We want to use these. We're supporting these Python versions. There are these sort of like low-level libraries like curl, like bzip, like whatever C libraries available, and you can choose from. And then this entire infrastructure is maintained by conda, and the CI is used to build for Windows, macOS, and Linux, and also for different like architectures, like macOS with Intel processors, macOS with M1 processors, and so on. And so if you have your recipe on conda, you can build for these like different platforms and different configurations very easily. It's like almost everything is automated, and there are bots that come around, and they also push version updates, for example, as a PR to what's called a feedstock. And the feedstock is basically the Git repository where the recipe lies in and where the CI pipelines are being run. And so this whole machinery is what we need to kind of, keep everything synchronized and make builds that work cross-platform on many different machines.
Awesome. So from the user experience, from the developer experience, I think we've clarified that speed is really important, right? You don't want to be sitting there like with the spinning wheel waiting for ages, particularly when trying to develop and be in the loop with your software. Besides speed or velocity, what are the other concerns that are most important, do you think?
I think speed and velocity are really interesting because they can actually unlock more stuff, like they can actually be sort of make things happen that you never thought could happen before because things were just too slow. Other key elements, I think security and trust are something that is in the package management space, something important. That's also something that we as Prefix want to focus on more in the future. We have pretty big plans for this quarter in terms of integrating more things around package signing and things like security related things.
Awesome.
Yeah. And I think for us, like sort of one learning that has always, like a lot of people are building tools on top of Mamba, for example, or on top of what we're doing with Rattler now. And that's really interesting for us to see. I think package management can be a big enabler of like tools down the line. Like also in the ML space, for example, people are really like building different tools to kind of run pipelines, and then each step of the pipeline spins up basically a different environment or refers back to an existing environment using a log file and things like this. So really, if you And actually, you guys at Outerbounds are basically doing that with Metaflow. Is that you can define your dependencies and you spin up an environment using, the packages that we ship.
Exactly.
So I think having nice APIs and things like this is a big enabler for tools down the line.
Well, yeah. I mean, to your point, one way we think about it at Metaflow is we want to make sure when people write machine learning workflows that they have in each step and at a flow level, but at each step have the necessary packages they need installed as quickly as possible without even needing to worry about it. So that's why, as you know, we use Mamba, and why you were so helpful in helping the team get the integration working. So that's incredibly cool. So we both know it's a pretty interesting time with LLMs and generative AI and foundation models more generally. I'm wondering if the environment and package management story changes for these, and if so, how?
Yeah, that's an interesting question. I mean, I think so far we haven't probably seen a lot of things changing. We definitely have a few ideas of things that we want to try out. In terms of like maintaining packages is pretty hard, for example. Like you kind of have to go look at the package, figure out for Python it's kind of decent, but for something else like C++, you have to read like the CMake script and figure out, okay, what dependencies does this package actually need? Because there are sometimes not real package manager, no metadata available except for something implicit in scripts and things like that. Or you have to read the README, right? And then it says like
Totally.
sudo apt get install blah blah blah.
Yeah,
And
I love that you say that.
and all of this should be replaced by pixie run start, right? So that's kind of the idea. And LLMs might be able to help us, like extract all of that metadata from all of these GitHub repositories and then build sort of the recipes that we can, and so that we can ship more packages more quickly. So that's one idea where we think LLMs could be interesting and help like building more packages. Apart from that, I mean, obviously LLMs can also sort of spit out installation instructions for different things and like tell you run pip install pandas or whatever. So I don't know if that is going to change anything in the near term. I could also imagine a future where, LLMs just write everything that you're importing on the fly. But that's like the crazy, like far out there future. So yeah.
Yeah, I'm also wondering on like the developer side using foundation models that come from a lot of sources, particularly with the size of these things and needing to fine tune or do rag, like even how much VRAM you need and that type of stuff. Whether that will change kind of how you think about package management.
So like definitely a lot of like package managers, let's say, and we just came back from PyCon actually a few weeks ago. And there was a lot of talk about like better CUDA integration into Pypi, and in the conda Forge space, we already have pretty good CUDA integration and things like that. And that is also like we're working quite closely with NVIDIA as the conda Forge team on like making sure that CUDA toolkit, these kind of packages work well. And you want to be able to kind of figure out, okay, I have this hardware. What's the best, package that I should run? Like what CUDA version needs to be supported to run this package and stuff like this. And that is something, I mean, that the conda ecosystem has been working on for quite some time, that we are working on Pixie. It would be interesting to sort of integrate VRAM into the mix. I don't think anyone has done that yet. But yeah, so that's the one side. Like you want to ship the optimized packages for your hardware, and that's especially important for AI stuff, obviously, because it has these like very like huge requirements in terms of GPUs, whatnot.
Yep.
And on the other side, one thing I've been thinking about, and that's also part of what I wanted to demo at the end, is like, aren't like AI models basically, couldn't you think about them as like software packages, right? Like you might, like there are somewhat versioned sometimes, right? Like,
Yeah, absolutely.
uh,
Ideally, they should
you
always
have,
be versioned, actually.
yeah, you have a lot of like, yeah, you have a lot of like sometimes slightly cryptic, I think, words at the end that say something like,
Absolutely.
okay, this is like this quantization was like that, blah, blah, blah.
Yeah, yeah.
And a lot of users probably don't really understand which one they should download. So that's the stuff that we should basically, like a package manager can to some degree at least take care of. And maybe like in the future, it would also be interesting if more like models would play together, right? Like,
Mm.
and then it's basically dependencies. Like maybe your vision model has a dependency on a large language model and stuff like that. And then if you express that correctly with packages, essentially, like you put the model into a package, then you could install all of these things together, and the package manager would make sure that everything is like at the latest, up to date and whatnot. And lastly, yeah, we've been thinking about ideas like, when you fine tune a model, it's basically like having a few sort of like changing a little bit of the whole big like blob, right? And so what if you install that fine tune, it's actually sort of like takes a base package that you might have already in your cache and then just maybe modifies that base package like a patch. And
Awesome.
so you like for your fine tunes, you might only have to download like a little add-on package.
Very cool.
And that is also like very straightforwardly expressed as like a constraint or dependency, right? Like your fine-tune model would depend on like a big base model and stuff like this. So that's some of the parallels that we see in package management and AI, and that's where we would like to go and exploit it more.
Awesome. So that actually brings me to, I am interested, someone also, sorry, my mind just went to wheels. When you mentioned wheels earlier, I didn't want to interrupt, but someone wrote in the chat eggs, and I think that may be of
Right.
what you
That
were
was the
thinking
one
of.
that I was
Yeah.
searching for. I don't know. They are so deprecated now. I already forgot about
Yeah.
them.
But thank you, Janice, for that. I've worked with wheels and pip and Pypi and poetry and lock files and different versions of all types of stuff, and I don't particularly want to. And I I'm just interested from your perspective as a tool builder. What is the ideal data scientist experience? Do they not even think about packages besides maybe I want this version because I know this version has this thing? Like,
Yeah.
what is the user experience in your ideal world? What you're building for?
So what we are building specifically, the user experience should be very straightforward. Like what the only two tools you need is Git and Pixie. And
Right.
so you do git clone whatever, like git clone that project. And then the second thing you should enter is just cd and pixie run start. And what that does is it uses a task that is defined in the pixie terminal to run whatever that project is supposed to run, right? And at that point, it will also check, do I already have all the dependencies installed? And if not, I create a new virtual environment. I put all the dependencies in there and at high speed. So it just goes and runs it on your machine ideally. And then you don't have to think about anything at all. Like the project author would have shipped everything that your project needs at that stage and make it runnable for you. And I think that's kind of the open source experience that we are envisioning. It's fast, should be really reliable and very easy to get into, and lower the barrier of entry also for like people that want to contribute to open source. Because right now, if you go to a number of Git repositories, especially in like the more like complicated things, like some of the research papers, let's say, they always like some of them have like, okay, create that conda environment and then install with pip and then do that and blah, blah, blah. And all of that can be expressed with a single pixie terminal and the log file. And other things like C libraries or C++, they have different instructions for different Linux distributions with the different installation commands that you're supposed to run with the different package managers, and then the package names are different and all those kind of things. And it's just always really, really cumbersome. You have to read like a README and figure things out. And Pixie solves all of that. Like Pixie can set up your compiler, set up your shared libraries, set up all your C++ dependencies, and you're just good to go.
Awesome. So we have a question in the chat from Will. What are your thoughts and plans on Pixie and the Jupyter ecosystem? I do want to throw into the mix there VS Code as well. I think because I personally I love Jupyter notebooks. I do use Visual Studio Code a huge amount for development as well.
Sure. Yeah, I mean, so Jupyter and I have a bit of a history because I worked at Quantstack, and Quantstack is one of the main contributors to Jupyter ecosystem. So I know the ecosystem very well. We would like to kind of deepen our integration with Jupyter. I think like it works perfectly if you just install Jupyter Lab in your Pixie environment that is local to your project. You can just do Pixie run Jupyter Lab and it starts up Jupyter Lab, etc. On that level, the integration is awesome. What we currently don't have, so there's also a project that's called Pixie Jupyter, I think. I need to check. It's from a third party, from a contributor. And I think he makes it more easy to kind of manage different kernels from within a Pixie project and select them from within Jupyter. And there's probably like some design space that we could explore where we somehow make it easier to have like one Jupyter thing, and then it can find different Pixie environments and sort of make them available in your one Jupyter instance or something like this. But really, like what we're focusing on right now is have that isolated like workspace experience where you basically have your project and then it would have its Jupyter thing and you could just run from there. And just like some people might be concerned about like having so many different virtual environments and it taking up space and things like this, but it's not actually a problem because we use hard links or ref links where possible, which means like on the file system, all these environments refer back to the same files. So you don't actually have lots of copies of the same thing. It kind of all refers back to a cache. So people shouldn't be really too concerned about spinning up multiple different environments with copies of Jupyter Lab, let's say. And then for VS Code, we are working and we have an open PR to VS Code Python that has the integration with Pixie. And that makes it possible to sort of automatically discover Pixie environments from within your VS Code Python experience. And that PR has been a little bit stalled for a month or so, but we have to get back to it. We have to bring it over the finish line. And I think that's something that we are targeting for next week. And I think that would be a huge quality of life improvement for VS Code users.
Awesome. And Will says awesome, thanks as well. I do want to jump into a demo second because I can't wait much longer, but I do want to get your thoughts on, as in your words, or I paraphrase, you're all working to improve the conda ecosystem by rewriting everything in Rust. Tell me about Rust and this decision you've made.
So if we like Mamba was written in C++, which worked really well and was also really fast, right? Like all of this is like fine. But then with prefix, one of the first things we wanted to do is also write a web server. And writing a web server in C++ is not a lot of fun because you basically have all of these memory safety issues that made it sort of a tough decision for us. And so sort of that web server thing is where we started to use Rust in our backend. And we also, Bus, who's working at Prefix, had already started to explore the idea of rewriting all of the conda things in Rust. So we also had something to work on that was Rattler. And we wanted to integrate some of these things into our website, just for example, to make sure that the version selection on the website works the same as in actual conda or Mamba or these things. And writing a backend in Rust, there's a lot more frameworks, a lot more tools. It's memory safe, so less afraid of attackers sort of exploiting memory bugs and stuff like that.
Yeah.
And that was the initial motivation for like starting this work. And it grew and grew. And some things we never wrote in C++, like version parsing, for example, was something that we didn't really have like directly in Mamba, but it was always sort of in libsolve. And libsolve, again, like worked perfectly, but it also has some problems. Like it's a C library. The code is extremely complicated. And I've tried to read it many, many times. And yeah, just like fixing it or changing it was never really possible. It's also maintained by a single person. And so over time, and one more like sort of important item is that libsolve kind of is not really thread safe. Like it works, like we haven't really gotten it to work nicely with multi-threading. So we kind of like took all of these things and then thought, okay, maybe we should like put some more effort into Rattler, like really work on it. And that's what we did. So Rattler is like a super sort of standards compliant implementation of all the things that make up conda packages. It makes use of a lot of the things in the Rust ecosystem, like Serde, to kind of parse all the JSON thingies into like proper Rust structs. Everything is typed and type safe, which is amazing. It makes refactors so nice and easy because, well, if it doesn't compile, you already know that you have a problem, right? And that's something in Python, like that I know also that the conda developers are struggling with, because a lot of like Python code, if it's a complicated project, can kind of evolve into a bit of a spaghetti situation.
Absolutely.
And yeah, so that's some of the benefits of Rust, including like the memory safety. And then we also started to work on our own SAT solver to replace libsolve in Rattler, which is called Resolvo. So that's one of the foundation or fundamental libraries that we are working on, and that we actually also have huge improvements over libsolve in these days. Like someone has just integrated Rattler into a bot in CondaForge, and something that took like 80 or I don't know, like at least 60 minutes with libsolve or Mamba is now taking like 6 minutes or something like that with our sort of new Rust code base. And
Wow, awesome.
he could even easily sort of make everything multi-threaded as well. So that's some of the sort of benefits that we can get now with Rust, is like super memory safe, thread safe language. And we also spent the effort to kind of go into the nitty-gritty low-level details to re-implement the SAT solver and all of that. And now I think we are in a good position to sort of harvest the benefits, which is, yeah, it's taking some time to get here, but now it's really ready.
Well, that all sounds really exciting. And speaking of harvesting the benefits, I'd love to harvest the benefits of having you here further. And I'd love to, for you to show us all a demo of Pixie.
For sure. I guess I can share my screen.
Yeah, you should have those privileges.
Amazing.
You are the co-host now.
I will use them.
Yeah, I mean, you got to, right?
Oh, that's all my LinkedIn and whatnot.
Yeah.
Hope I didn't spill any secrets there.
What an influencer. So yeah, can you just make your yeah, great. That's even bigger.
So
a little bit bigger would
let's
be.
just let's get there. Let's first make sure that the thing works. Okay, so now I'm in the Pixie repository, right? Like, and we have some examples in the Pixie repository.
Good.
Okay, so let's start with one of the features of Pixie, which is global installs that I haven't actually mentioned before. So one thing you can do is, for example, do you know bat?
Not sure.
It's like cat with wings. So anyways, like I can just do Pixie global install bat. And then it goes and downloads like the repository data from CondaForge, let's say, and makes these executables globally available. So that means bat was just installed version 0.4. And now that I have bat, I can do things like bat, Jupyter Lab, pixie.toml. And it's cat with wings. So we
Yeah.
have like a colorful sort of way of looking at these text files.
Lovely.
And so we've already talked about the Pixie Toml. And this is a Pixie Toml. It's an example project for Jupyter Lab. You can define some metadata. You can define an author, stuff like this. Like we kind of took a few ideas from, I don't know, a mixture of PyProject Toml, Cargo Toml, and all of these other sort of things that are used in package managers. And Pixie Tomls are sort of completely language independent, but we also do support PyProject Toml. So I just want to point that out as an alternative to Pixie Toml.
Great.
And then in the dependency section, you define whatever, like you need Jupyter Lab, NumPy, Matplotlib, all your favorite tools. And as I mentioned in the tasks, like we always recommend to have at least a start task. You can have more tasks, and tasks can also depend on each other, which is also interesting. But this task is just, okay, I want to start Jupyter Lab. So now if I go to that example, I can do pixie run start. And again, like this should be, like if you clone a repository, pixie run start should be the only thing that you should have to do. If I run this, it will already start Jupyter Lab, which is kind of boring because things were already set up. Yeah, well, that's just Jupyter Lab. But let me go back and show you what actually sort of happens. We have this Pixie folder that has an env folder and that has like the default env right now. And that contains everything. Like if you would look at the bin folder, then there's a Python here, right?
Yep.
And so if I remove this Pixie folder and pretend that I would be like a fresh user, because that's Pixie folder, you should not check into your Git repository, just to be sure. And then I do pixie run start. Like at this point, it's gonna download and install and link everything that you need, right? So that would be your first user experience. And then let me just show you something else that might or might not have a wow effect. So I'm doing something else in this example. So this example is a much more complicated Pixie Toml file with features and multiple environments, et cetera, et cetera. I'm not going to talk about this because that goes maybe a bit too deep, but I can do remove the Pixie log file. And if I do Pixie run start now, it's going to resolve all of these different environments. So first it downloads the repo data, and then it's resolving all of these environments at the same time.
Wow.
So that was like over 10 environments sort of in parallel resolved.
And there were all different versions of Python and stuff in there as well, right?
Different versions of Python, different versions of Polars, etc. Whatever. Like you can do whatever you want in these environments, right? Like, but really, yeah, all of these sort of refactoring made it possible to use the safe and sound multi-threading and just do loads of things in parallel. And maybe one other interesting feature, and I actually don't, maybe that's something that we can find in this. No. So one cool feature that we have, and that I just want to mention because we talked about development environments and production environments, is we have a concept called solve group. So what you can do is you can say, I have one environment that has my production, like it's the minimal set of things that I need to run in production, like Python and NumPy, let's say. And then you have a development environment that maybe contains PyTest and I don't know, whatever you need to run, like rough as a formatter, etc. And what we can do is we can define that as a solve group. That means Python, NumPy, PyTest, and rough are resolved together with versions that are compatible with each other. But then you can say, okay, your production environment only needs those two things, and the rest is like an extension to the production environment. And Pixie will split those dependencies up and make sure that everything is compatible. Your test dependencies are the same as your production dependencies. So that's one of the features that's called solve groups, which is like pretty interesting, I think, in Pixie.
Super cool.
Now I kind of said that we would maybe look at some AI stuff. So maybe a cool example is Whisper. I mean, it's probably not like the most sort of like people probably have seen it before, but what's cool is that if you use Whisper, and we're using Whisper CPP here, if you use Whisper by yourself, you probably pretty often have this issue of needing FFmpeg maybe to convert some stuff, right? And you can get FFmpeg very easily from Forge. So, and on all the platforms that we support, like even Windows and stuff. And then we also have some tasks here, right? Like, so I've built Whisper CPP stream. I don't know if you've tried to build Whisper from source. Probably not. Yeah, it's quite annoying. And for the stream thing, you do need something called SDL, which is like another C++ or C library that you can get easily from Forge, but it's kind of more difficult to get it consistently on the different platforms otherwise. And so, to run this, I can just do pixel run start, and it starts Whisper, and it also has the model as a package. So the model is part of the sort of environment that is installed with Pixie. And as you can see, it's doing a live transcription and actually seems to know the word Pixie, which is kind of cool.
Very cool.
Yeah.
What does it do if you speak German? Oh, we've stopped, but
let's try. Guten Tag, Hugo. Ich hoffe, es geht dir gut.
Oh, wow.
You see, so now it understood that I speak
it's fun.
language.
We're on YouTube, but it was like, no, don't say that. Don't say that. Don't say that. Guten Tag, Wolf, wie geht's?
I have the airports in, so it doesn't hear you, but
of course. That's really cool, man. Well, definitely everyone should. So how do people get started with Pixie? Remind us.
Yeah, it's the easiest is to go to pixie.sh and you see our cute mascot. And then the installation instructions are literally one line, right? If you want, you can curl it.
Great.
For Windows, there's the PowerShell way, or you can use winget. It's also interesting. You can also get it from Homebrew. You can get it from Forge. You can get it from Alpine Linux and a number of different Linux distributions. But yeah, the most straightforward way is to just curl it. And then it's, you find everything here in the documentation. Usually it's Pixie init. So you can run Pixie init, your project, that creates a new folder. You then change your directory to that folder, and that will already kind of create the Pixie TOML file. Then you can do things like Pixie add Python, which will edit your Pixie TOML file and run a resolve and kind of create a log file and all these things. And that's mostly what you need to get started. And then there's a whole lot of other things to learn about that make it quite powerful.
Awesome.
And then maybe for the people that also want to learn how to build a conda package, one of the other exciting things that we're working on these days is called Rattler build. And we spoke about how difficult it is to kind of build a C project, and Llama CPP and Whisper CPP are two C++ projects. And Rattler build makes it pretty straightforward to do that. So you can define this kind of recipe, which is a YAML file. So that defines your source, patches, outputs, etc., and then build steps like using CMake to build things. And then what you can do is Rattler build, and Rattler. So Rattler build is another sort of not really consumer facing at this point, but package builder facing tool that we're building on top of Rattler as a library. So it's the same foundations as Pixie in a way. And then you can just point it to the recipe, and it will download the source code. It will set up your build environment, and then just run the build script. And again, like that's also cross-platform, so that should work. Like if you set up everything correctly, it works on Windows, Mac OS, Linux. This is building a C++ package. I don't think it has been that easy to build a C++ package ever before.
Dude, I'm scared. You make it look all too easy, actually. We've got some great questions in the chat, and your friend and colleague, is it Ruben? Ruben Arts has
Yeah,
come in and answered.
yeah, I know that guy.
Awesome. There was a question around Pixie is great for package management. Andy Lee said, would it also be suitable for packaging? Thank you. Ruben replied, you all are heavily working on Rattler build, which will serve as a library in the future for Pixie build, which would build a package from a Pixie project.
Yeah, that's totally correct. So
yeah,
that's our sort of medium-term plan. Like that's one of the things that from the start of Prefix or from the start of Pixie build was something that we're working towards. It's not, yeah. There are a lot of like open questions, like how should things work? Like how do you configure stuff? Like what information do we put into what file and these kind of things? So right now our mission is to build Rattler build, which builds packages from a recipe. And that recipe looks a lot like the one from conda build, which is sort of the historical tool that is used everywhere.
yeah.
And there's also an effort actually from Anaconda to map from an old recipe format, which is called MetaYAML, to the new recipe format, which is called recipe YAML. And so there's an automatic or semi-automatic translation to the new format that Rattler build understands. And that's something that we are planning to roll out to CondaForge within like this quarter, essentially, until August. And something that we're extremely excited for, to be honest, because conda build is like pretty bad. And we want to like provide really nice experience for people that want to build new packages.
Great. We have a question in the chat from Ella Charmed. And Ruben's just answered it, but I'll say it. So to share with teammates, we just commit the lock file.
Yeah. Yeah, that's the idea. I mean,
amazing.
Most of the time, that's what you want. Like sometimes, I mean, yeah, sometimes you want to test against the most recent versions and things like this, or you don't want the overhead of the log file. Which is like you can also remove the log file in CI and re-resolve your thing and stuff like this. So that's all possible.
Exactly. Yeah. We've got a couple of questions around stability of the current alpha version and roadmap. So I'm wondering if you could first speak to
who said alpha?
Snowman said alpha. So please
I don't like Pixie is not really considered alpha at all right now. It's like like people are using it in production for sure.
Yeah.
And it works. And if it doesn't, please find an issue.
Yeah.
And what was the like stability?
Yeah. I mean, we should consider it stable and usable in production, right?
Yeah. Yeah. I think like we went through some iterations, for example, in the log file format. So the initial format was different from what it is now, but we've always had an upgrade path. So I think we are really committed to like not break the experience for users. And for example, the newest Pixie version can still read a log file from an old Pixie version. Yeah, that's awesome. That's the whole idea.
And then how about roadmap? And perhaps stop sharing your screen.
Yeah, for sure.
So that everyone can see our massive heads. I'd probably prefer to stare at the screen. But yeah, so yeah, what are you most excited about on the roadmap for the rest of the year, let's say?
Yeah, like I said, like Rattler build is one of the things that I'm really excited about and rolling that out to CondaForge and sort of all the things that it hopefully enables, because like a typical build for CondaForge right now for like what's called a no-arch package, which is like pure Python, maybe still takes like 6 minutes or something like this. And I think with Rattler build, we can get that down to under 1 minute. There are some other fundamental issues in the CondaForge world, something that's called the CDN sync, which is pretty annoying because when you upload a package or create a package on CondaForge, it can take to like 30 minutes, sometimes more, to kind of trickle down to the CDN and to the repository data so that you can actually use it. And we've worked on something that's called sharded repo data, which means that instead of having this gigantic repo data file that's like actually over 200 megabytes uncompressed, it compresses down to like 20 megabytes. Instead of having that big file, we split it up into many, many small files. And it's like an extreme amount faster than like the previous sort of attempt. And we are working closely with Anaconda to kind of roll that out. And we already have the implementation in Pixie, and we have a sort of beta, kind of like we have an experimental way of like shipping these files under the fast.prefix.dev/conda, for example. You can find this sharded repo data index. And that's something we are quite excited about. And then everything down the line in terms of security. So we want to integrate with something called xtensor. I don't know if you've heard about it, but it's basically a way. Yeah. So we want to make sure that people can sign their packages using this technology. And I think it's basically becoming the de facto standard for most package distributions to make it possible to sign the packages with xtensor. So we want to have that integration. So that's basically kind of like there's a lot more smaller things, especially in the package building space that I'm super excited about. I'm not sure if the general population is so excited about it, but we want to give people the power to kind of build their own packages. And that's something that's currently pretty, like, that's kind of missing from the conda world. It's like, we want to just make it really, really smooth, really nice. And I think that will also feel very powerful for the people that use it. So
that's awesome. So definitely install Pixie, everyone, and then run Pixie run. If people want to get in touch, go to prefix.dev, or you can follow Wolf on Twitter as well, or the platform formerly known as Twitter at WUOLF. You can also find him on LinkedIn. Are there other ways to get in touch with you, or other things to check out?
I think maybe actually the best way to get in touch is to join our Discord community and hang out with us. And then you can also talk to other people from the team, not just me.
That's awesome. And you can, on prefix.dev on their landing page, which I've linked to, there's a join our Discord server button. Exactly. So you can, I joined recently. So
yeah. You
very
came with a good GIF.
Yeah. It was the dancing cat, wasn't it?
Yeah.
I was trying to remember which. I mean that. Yeah. Look, let's. Look, Wolf. This is all super exciting stuff. I want to thank everyone for joining, but also thank you for your time and expertise and all the work you do for the ecosystem as well. It's much appreciated. So,
thanks for giving me the opportunity.
Absolutely. And people in the chat, Will's saying that was awesome. Thank you so much. Andy says great talk. Thank you very much. So seems like everyone.
I hope next time we have an actual fireplace, and
that's it. Yeah, we need it. And I mean, last time we saw each other, we were, cheersing good springtime beers in Berlin. So I hope that happens again sometime soon. All right. Thanks, everyone. And do subscribe to us on YouTube so you get access to all these wonderful things. And thanks once again, Wolf.
Thank you. Bye-bye.
Awesome. That was fun, man.
Yeah.